All right, review day 2 of 3. Video number 1 was 20 minutes long. This is video number 2. I'm going to try to shoot this one again and keep it brief. So let's get started. Switch the camera around and here we go. You should have the document called Final Exam Study Guide Part 2 of 3 open and ready to go. And I'm going to get started here right away. Question number 1 talks about writing a fraction, writing a decimal as a fraction. On the top here, a reminder that terminating decimals end at some point, and because they end, we can actually choose the decimal place, the tenths, the hundredths, the thousandths, and so on that they end on. So in this particular example, this one ends on the second one. That one is the hundredths, so we would go ahead and say 34 hundredths. And you could surely divide that by a common factor, and you can go ahead and get an accurate answer there. And that accurate answer is 17/50. Hopefully you have the same thing, right? So we wrote that as a fraction. Now, though this one doesn't ask about it, there was also in this same topic the idea of turning repeating decimals that do not end into fractions as well. And I have an example over here as a way in which to do that. Keeping an eye on the time right now, just be aware that this exists. You can go back and look in your notes. If on Get More Math, a question about repeating decimals pops up, you can check here for the basics, or if they get a little bit more complex, either go back and look at your videos, search a video online, or meet me in Zoom, and I can coach you through anything related to repeating decimals. For now, let's go ahead and move on. Question number 2 talks about right triangles and the Pythagorean Theorem. Remember the Pythagorean Theorem? It's when we had the two legs, the two short sides, A and B. When you square them and add them, you equal the long side. We call that the hypotenuse, or side C. So the basic version of the Pythagorean Theorem is a squared plus b squared equals c squared. This problem is a word problem. It says a right triangle has legs of. So as soon as it says legs, we know that this and this are the two legs. Those are the short sides. That's A and B. Find the length of the hypotenuse. That's side C. That's the thing we don't know. And it tells us round to the nearest tenth. That's one decimal place. So I went ahead and put the numbers in. Instead of a squared plus b squared equals c squared, you can see I have 13 squared plus 14 squared equals c squared. I squared them both. I added them together. I got 365. And then to get rid of the squared that's right here and get back to plain old c, I need to use the square root. So go ahead and do the square root of 365 right now. Choose the correct answer. And you should be choosing 19.1 inches. Right? That's the correct way to take the square root and then round to one decimal place. Next question, basically the same concept. It's a slightly different style word problem. These are sometimes a little bit weird because you have to interpret them a certain way. This person, Cheryl, climbs a ladder that is 18 meters tall. She wants to ride a slide back down to the ground. It doesn't tell us how long the slide is. That's why there's a question mark there. And then she has to walk from where she lands back to the beginning of the climb. So the walk back, they tell us, is 11 meters. Ultimately, they want to know how long is the water slide. So you could probably guess, here's your 90-degree corner. So 18 and 11 are your A and B. So I put 18 and 11 in the A and B spot. Once again, I squared them. I added them up. Go ahead and finish this problem. And you should get 21.1 meters if you round to one decimal place. Very good. Now let's move on to number 4, the volume questions. 4, 5, and 6 are all volume questions. The first one talks about a rectangular pool for the backyard was made by connecting two smaller rectangular pools. Now, this particular kind of rectangle wasn't one we studied, but it is an easy enough formula. The volume for a rectangular solid is just length times width times height. You just follow that formula. So here's what we have. We have two pools. The first pool tells us it's 3 by 7 meters, right? 3 meters by 7 meters by 10 meters. So I'm going to put a 3, a 7, and a 10. And if you mix up where the 3, the 7, and the 10 go, it doesn't make any difference because the formula is just 3 times 7 times 10. So if we were just finding the first shape, 3 times 7 is 21, times 10 is 210, and this is in meters, so meters cubed. To solve this problem, you're going to go ahead and calculate the volume of the second one as well, get the actual number, and then because a total is adding them together, You're going to add the 210 and the number you find here together, and then make your choice A, B, C, or D. Good. Now moving on. Question number 5 deals with volume of a shape we did study, a cylinder, like a can of soup or a can of soda. Formula for the volume of a cylinder is pi r V equals pi r squared h, right? R is radius, h is height, and V is volume. This problem gives us some information. It tells us the height is 14, it tells us the radius is 15, and it wants us to find the volume. So you'll notice that we have volume is, right, because we don't know the volume yet. So volume is 3.14 times 15 squared, because I put in the radius spot, I put the 15. And in the height spot, I put the 14, because the height is 14. Go ahead and use your calculators and do 3.14 times 15 squared times 14. And yeah, you should get 9,891 centimeters cubed. There we go. Number 6 is a pretty similar question. It's still a cylinder, so still same formula. But what's different here is that there's different bits of information provided. This one tells you what the volume is, so you notice that I put that number in the volume spot. And it tells us what the radius is, so I put that number in the radius spot. And it asks, what's the height of the cylinder? The height of the cylinder is the missing piece, so that stays a variable. For the purposes of this example, I simply wrote down the word instead of using the letter H, but it wouldn't really make any difference. You'll notice I went ahead and took the 4 squared here. So 4 squared is 16. 16 times 3.14 became 50.24. And because 50.24 was being multiplied by height, I divided both sides by 50.24. 50.24 cancels out. You're left with a division problem that you could do right now to get the height. And you're right, the height is 15, in this case, millimeters. Good, let's move on. Number 7, this one is asking about something about functions. You might remember functions had that thing that was the vertical line test. I'm going to switch. Let's see here. The vertical line test was, there's my coffee. Here we go. Was this guy where you take a vertical line, pencil would work, and you drag it across the screen. If when you drag it across the screen, it touches only one point, then it's a function. If when you drag it across the screen it touches more than one point, then it's not a function, right? So we're looking for things that are functions. And in this example, I'm going to go ahead and make myself a vertical line, and I'm going to drag it around here. This only ever touches at one spot at a time. Same thing here. So these are both, A and B are both functions. So you choose C or D. Which one do you think fails this test? When I drag the line across it, it's going to hit more than one spot. And that's right. C passes the test, but D fails the test right here. Okay, D fails the test at that spot. What I would say is when X is, let's see, if this is -1 and -2 and -3 and -4 and -5. So when X is -4.5, Y is two different things. So -4.5 partners up with two other Y values. That's bad news, right? That gives us that vertical stack that is not good for functions. So be very, very careful with that. So D would be the non-function. Down here, what's your choice? The reason why it's not a function, correct answer when you get a chance to look at them, is B. There is an input value. That was the -4.5. That corresponds with more than one, right? It corresponded with two output values. So because of that, it was not a function. A little definition of function down here. And moving on. Number 8 and 9 both ask about proportional relationships. A proportional relationship simply means that if you divide the Y value or the output by the X value or the input, you get a constant change. Like one movie ticket's $5, or two tickets are 10, or three tickets are 15, right? We get the idea that the jump each time is 5, and we also understand that if we don't buy movie tickets, we don't spend any money. That's what describes a proportional relationship. This constant change and the fact that it goes through the origin. So you're always looking for both of those things. So I'm going to begin at 0, 0, because if it's proportional, and it says that it is, if it's proportional, it must go through the origin. It must go through the origin if it's proportional. Then it says she purchased 40 necklaces, so 40 is over here, so somewhere on this blue line here is going to be our second point. And $160 is right here. You can see where they touch. So I'm going to make myself a diagonal line. I'm going to extend it beyond, and then just because it's nice to be clean, I'm going to go ahead and neaten that up. That's how you graph a proportional relationship. In Get More Math, you might recall it's easy to get pink dotted if you just kind of do it out of order. In Get More Math, you put your first dot on the origin, you put your second dot wherever the second dot would go, and the blue line will snap. And if it looks right, then go with it. If it doesn't look right, use the trash button and then start over. All right? First button here, second button there, and you'll be in good shape. Question number 9 asks, which of these does not show a proportional relationship? So which one fails those two criteria? The criteria was it's always the same, which only means that our line goes in a straight line. It's not curvy, it doesn't bend, it doesn't change, it's just straight. And which one goes through the origin. So over here, we're looking for which one doesn't do that. So go ahead and make your choice. And good. Choice B is not proportional. Choice B is not proportional because it misses the origin by going, it looks like, 3 spaces above. Last question. What is the rate of change seen in the graph below? Now, one more time, you saw me do this in class many times. I talked about my snowboarding skills, and I talked about how I enjoyed taking selfies for my wife when the slope looked like this. And this was a difficulty of 0, which was my favorite slope. This one was undefinably difficult. Nobody had ever survived something like this. So we would call something like this a no slope, which is going to answer your question. And then we would talk about, now the video might be backwards, so I'm not really clear on which way to hold my pen for the positive versus negative. So I have a drawing made up here. Positive slopes go up and to the right. There's my no slope. There's my negative slope up and to the left, and a slope of 0, my selfie slope. And with that in mind, I can just look and see that there's no slope on this one. It's no slope because of that old battle horse that we use to describe slope. It's rise over run. The way you do rise and run is you pick any 2 points. It doesn't really matter which 2. You count how much it changes vertically first. So this one changes 1, 2, 3, 4, 5, 6, 7 spaces. That's your numerator. And then you count the horizontal change, how much it runs. Now it has to go left or right to run. This one doesn't go right or left, so it's 0, and this does not equal 0. It equals no slope, right? This is undefined. If you put it into a calculator, it would not work. Now, what I'm hoping is that this video is shorter than the last one and gives you what you need to be able to successfully complete the middle chunk from Get More Math. Good luck.